Hi all! Today I'm gonna talk about concurrent features in React 18. My name is Fernando Rosenblit. I'm a senior software engineer at Bootstrap and I live in Argentina. In the agenda for today, we are gonna cover what is concurrency, we are gonna compare the legacy and the new render model, we are gonna talk about how to address performance bottlenecks in React 17, we will see the new APIs that React 18 delivers, we are gonna explain how concurrency works under the hood, and we are going to discuss what happens in server-side rendering and the new suspense component. So to begin with, let's define what is concurrency. By definition, it's the execution of multiple tasks in an overlapping time period. For React, it will give us the ability to prepare multiple versions of the UI at the same time. So let's see how the legacy render model behaves. In React 17, it has three main characteristics. The all state updates will be treated as synchronous, unique, and uninterrupted transitions. Once the render process starts, there's no way to interrupt it. It's a one pass execution function. In that period of time, the UI will be blocked, which means we will have a lack of hierarchy. Every state update will be considered urgent. There's no way to distinguish between urgent and non-urgent state updates. So, from a set state call till the DOM was updated, the UI will be blocked, which can be an issue depending on how expensive is the render, because if it takes 3 or 4 seconds, the UI will be blocked during that period of time. If in between an event happens, React will have to wait until the current render process finishes in order to handle it. There's no way to interrupt it. Let's see it in action. Here I prepared an example. It's a really simple web app that fetches all the characters from the Rick and Morty API. We have 9,912. So let's see how it behaves in React 17 if I want to search them by name. I have a search input, for example, and I would like to get all the characters with the name Rick. I will add a keyboard to the screen so we can see it while I am typing. So let's reset it really quick. As we see, I deleted the input value and the UI get blocked. The UI is blocked because it's rendering. So let's do it again. If I try to search Rick, we see the UI is blocked. I am typing and I'm not seeing the current value of the input because the main thread is busy trying to render with the previous value the result. So we can see it's taking really long time. I can type and the UI is blocked. So this is expected behavior of JavaScript blocking the main thread while it is rendering. So which are the possible values to address these performance bottleneck issues in React 17? Well, there are different options. The most popular one, I think, is the debouncing or throttling the input value. We just play around with the timeline of our program and we delay the state updates. Another option that is popular is to virtualize the list. It's a practice of adding or removing elements from the DOM based on their position in the viewport. This gives us the chance to render a smaller amount of elements instead of rendering a big list all in one single pass. Another option can be to filter and paginate on the backend to decrease the amount of elements, but sometimes this is not available in our APIs. Another option could be to render the list on the server, to which that we all know that on the server the rendering is faster than on the client. And last but not least, right now we have React 18 to the rescue. So the new render model of React 18 is completely the opposite from the previous one. In the previous one, it was synchronous. Right now will be asynchronous. The new render model works in a non-blocking way. And we have hierarchy. So with hierarchy, we are gonna be able to distinguish between state updates. Some of them will be urgent and others will be non-urgent. So from the set state call till the DOM update, if in between an event happens, a mouse click, a mouse move, whatever it is, React will be able to interrupt the render, handle the event, and then resume the render. Interrupt it and resume based on the activity of the user in our UI. So how is it possible? Well, the new version of React ships in with two new hooks. So React introduced the concept of transitions. Transition it's a transition between a state between renders. Let's say it. So by default, if we call a set state, this call will be treated as urgent. By default, all state updates are urgent unless we wrap it into the start transition function, which will convert that state update into non-urgent. What it means is that first React will give priority to all the urgent updates, and once all of them are processed, it will start processing the non-urgent ones. We also have a hook called use transition that it will return exactly the same function start transition, but it adds a flag that we usually call it is pending. This flag will return the current status of the transition. It's just a boolean true or false. This is really important because we usually display in the UI loading states based on promises that we are waiting to resolve or not. But right now we will be able to print in the screen loading state spinners based on the status of the render. Let's see it in action. Right now we have exactly the same example that we see in the previously. But right now, with this button, I will switch to React 18, and we are gonna wrap the set state call that updates the input into a transition. So I will first add the keyboard to the screen. So let's see it in action. As I start typing rig, for example, right now we have a loading state that it's printing rendering, so we can keep track of the status of the render process. And what happens right now is that the UI is not blocked anymore. I can continue update the input while React is rendering, while React is preparing the new version of the UI. This is something really, really good, and it gives us the chance to avoid users leaving our page because it's really laggy. And the other new hook that React introduces is called deferred value. Use deferred value. What this hook is gonna do is something similar like what transitions do, but it will return an updated value of the state while a non-urgent state is triggered that will update the value of that state. So it will return an outdated value, and once the new value is available, it will update it and return the new one. Let's see it in action. So I prepared here another example. I will open the console too, and I will add to the screen the keyboard again. So let me see. Okay, here it is. I will increase the amount of the location. So, okay, this UI will show all the locations where all the Rick and Morty episodes happens. I'm gonna enable React 18 with default value. So, and what I'm gonna do is I will do a bulk update of all the locations description in one single pass. So let's do it first with React 17. If I type tabun, is I type this is the description. So we can see here how long it takes React to render, and in between the UI is blocked. As we can see here, let's wait until the render finishes. Yeah, as we can see, this is really expensive and the main thread is blocked for a really long period of time. So let's reset it. It will take some time, sorry for that. And I'm gonna switch to React 18 and wrap the value of the input into a use deferred hook. So right now what will happen, so here at the right in the console, we are gonna see the real value of the input and the value that the use deferred value returns. So I will type this is oh, here it is. So first of all, the UI was not blocked, it's not blocked, and while it is rendering, I can still type. But the most important thing is here. The initial state, the input was empty and the deferred value was empty. On the next frame, the real input value was t and the deferred value was still empty, and so on, so on, so on, so on. And here it is at the end. When I stop typing, the value of the input was this is, and the third value returned exactly the same value, which is something that in the previous renders didn't happen because it was empty. So this is how use deferred value works, and we can see we can still type while React is rendering in the background. I will remove the keyboard. I will switch again to the slides and everything is beautiful. It sounds like magic, but how does it really works under the hood? How React is being able to interrupt and resume the rendering? Well, everything starts when React adds a new task to the task queue or the update queue or the update task or whatever we want to call it. So the function that is in charge of doing that, it's called unstable schedule callback. This function will receive as an argument the priority level and the callback itself, that the callback is the task itself to be executed. So this function will define a timeout, that the timeout is based on the priority level, and the value depends. For example, for an immediate priority level, the value will be minus 1 milliseconds. For a user blocking, it will be 250 milliseconds. Normal priority 5,000, and for example, for an idle priority level, it will be the max big int. That is a function. It will probably be never executed. So then we need to define the expiration time of the callback, which is the current time plus the timeout. And the timeout is based on the priority level. Once we could define those values, we need to build our task object. The anatomy, it will include the callback itself, like the task or the date that needs to be executed, priority level, the start time, the expiration time, and last but not least, the sort index. And the sort index will be equal to the expiration time. So based on the priority, it will be the position inside of the array of the task. So with an idle priority, it will equal to a current time plus a really, really long number. So it will be at the very end of the queue in the array. And the next thing that we need to do, we need to push the new task that we have already created inside of the task queue. So the next thing we need to do is scheduling the callback, the task to be executed in the next frame. So we need to add it to the event loop. We have different options for this. For Node.js environment, React uses the set immediate, which receives as an argument the perform work until deadline, that is the callback that the previous function received as an argument. For workers or DOM environment, React uses the message channel. It's practically the same behave. And last but not least, for non-browser environment, it uses the set timeout function with the trick, with setting the timeout to 0. The problem with that is that the set 0 doesn't mean immediate for React. For JavaScript, this function adds a minimum of 4 milliseconds delay, which means it's not immediate. That's the behavior in all browsers. I know that, for example, in the new version of Chrome, this for minimum of 4 milliseconds was removed. But anyway, these are the 3 ways React can schedule the callback to be executed in the next frame. And once the callback is scheduled, here it comes, the difference between React 17 and React 18. So we need a function that will programmatically inside a while loop execute one of the tasks inside of the task queue until the task queue is empty. React 17 do it with a function that is named work loop sync, that it will be parametrically call a function called perform unit of work, and it will receive the first element of the task queue. While the task queue is not empty, it will continue executing by one. But React 18 uses a different approach. It uses the work loop concurrent. It's exactly the same while loop, but it has a difference. It includes one more check, that it's a call to a function called should yield to the host. Yield to the host means surrender and free the main thread and give the control to the browser again to the main thread. So if there are tasks inside of the task queue and it's not time to yield to the host, it will programmatically call in each one of the tasks inside of the task queue. Before we dive deep into what should yield to a host do, let's see what is input pending. Is input pending is the first contribution by the Facebook team to propose and create and implement a JavaScript API. What they said is that it tells you wherever there is input pending. Developers can use this information while running JavaScript to decide whether they want to yield back to the browser. It's just a function that will return true or false based on the status of the browser. If there's an input event in the browser that is pending to be handled, it will return true. For example, if the user clicks on the mouse, makes a mouse click, it will return true. If the user doesn't do anything, it will return false. We can access it through the navigator object in Chrome. It's navigator does scheduling that is input pending. You can test it, it will return true or false. That's it. Something to mention about it is that this is a new API. This is a screenshot from Can I Use. It's available from Chrome version 87, the same in Edge, Opera from version 73, but it's not available, for example, in Safari or Firefox or even the old Internet Explorer. So once we could understand what is this input pending meaning and what it returns, let's dive deep into the function should yield to the host. First of all, it defines a time elapsed. The time elapsed will be the current time minus the start time. So if the time elapsed is smaller than 5 milliseconds, it will return false and the while loop will continue executing the next task. If is input pending, if the API is available, it will do more checks. For example, if the time elapsed is smaller than 50 milliseconds, it will return the value of is input pending. Is input pending by default returns if there are discrete input events. A discrete input event is, for example, a mouse click. If the time elapsed is greater than 50 and smaller than 300 milliseconds, it will still return the value of its input pending, but it will also catch a continuous input. And of course the discrete ones. The continuous input is, for example, a mouse move. If the time elapsed is greater than 300, it will return true, and we should yield now. We should give back the control to render and give back the control to the browser. And by default, if its input pending is not available, it will return true after 5 milliseconds. So what this is gonna do is that we are gonna have some components in our tree that will work in a concurrent way, and some other ones that can be achieved in a synchronous rendering. Let's say, so both render models can live together. It's not a matter that when we start the project, decide if we are going to use concurrency or not. It's our decision to decide if we need it or not, based on each use case. So, for example, these are two screenshots from React 17 and React 18. This is a task inside of the performance tab. For example, in React 17, in a work loop sync, we can see that this is a task that took a really long period of time. In one single pass, all the while loop was processed. It took 36 milliseconds. On the right, we have an example of how this looks in a concurrent way. We have a call to the work loop concurrent, and as we can see, it's divided. The whole render is divided into really small chunks. And in between, it's giving back the control to the browser and going back to continue render. It's a matter of interrupting and resume the rendering. If we zoom on the concurrent rendering, we have the work loop concurrent, function. And in this case, it could perform a unit of work that was a task. Then it called you should shield to the host to see if there's an input pending or not. In this case, it returned false, so it continued executing the next unit of work. So this is a diagram of how everything works together. So we have the work loop concurrent that we call the should yield to hold function. If we return false, it will perform a unit of work. After that, it will call a function called has more work. If there are more tasks inside of the task queue, it will return true. It will come back again. It will check if should shield to the host or not. If it returns false, it will execute the new task. If there are no more tasks pending, this function will return null. Instead, if should yield to host returns true, the work loop concurrent will return a root incomplete. That it's a flag, and it will return a closure. The performing unit of work will return a continuation callback. It's a closure of itself with the flag indicating that that task couldn't finish on time. So it will be resumed in the next call to the work loop concurrent. So this is all for client-side rendering, but what about server-side rendering? We can define server-side rendering as a four-step process. We have first on the server, we need to fetch all the data. Then after we fetched all the data, we need to render all the HTML. Once all of the HTML is rendered, it's sent to the client. The client will have to load all the code, and after that, it will have to hydrate. Hydrate is a function that will recreate all the components that are in the screen. The problem with that is when React is hydrating, the UI is blocked. And hydrating is a really expensive process that it can take 2, 3, or 4 seconds. But it's okay because in one single pass it has to recreate all the UI and all the components to make them interactive, because let's remember that server-side rendering, when it returns the HTML, that is not interactive. So this is when suspense came to the rescue. In React 17, suspense was a wrapper only for lazy loading components. In React 18, it will be different. Let's imagine we have this page structure. We have an article that is nested inside of the section. Hydration is taking a lot of time, and we decide that maybe that article that is nested is not really important to be hydrated in the first paint. So what we can do is we can wrap that article into suspense, and we pass a fallback that is a spinner. So what it means is that we are gonna do a selective hydration. React first will hydrate everything except that articles. Once the previous hydration is ready, React will start hydrating all the components that are wrapped inside suspense. We can also nest suspense elements, and React will start from the top to the bottom of the tree, hydrating one by one. So as with transitions, we have the ability to say which UI elements are urgent, let's call it urgent hydrations, and which ones are non-urgent. But what happens, for example, okay, this is how it will look after the hydration of the article is finished. What happens if we have a lot of nested components that are wrapped inside the suspense boundary and the user clicks inside one? If the user clicks inside one, React will automatically give priority to it, hydrate it, and then continue with the other ones. So the question is, what is most important, to be fast or to be responsive? We can associate the legacy render model to be faster than the concurrency one, because the this operation that go into the browser, going back, going to the browser, going back, going to the browser, and going back, it's time consuming. It's really a small time, but it's time consuming. So the concurrent render is slowest than the previous one, but it gives us the chance to be responsive. The UI will keep always responsive, something that doesn't happen with the previous one. So it's a matter of a balance between speed and being responsive. We have to choose which one to use depending on the use case, and a balance of both. I think it's the most important thing to understand. It's not choosing one or another one, it's a mix. So keeping the page responsive is really important, but fast rendering is also important. So the challenge is here is to be able to distinguish which components are expensive, which ones are not, which operations are urgent, and which ones are not. That's all for today. I hope you enjoyed the call, and see you in the Q&A. Thank you.
Hi, Fernando. Great presentation.
Thank you.
Just a reminder to everyone watching that you can ask your questions to Fernando. Please make sure to drop them in the comments so we can review them and ask him and ask Fernando the presentation. So while we're waiting a bit for some questions to pop up, I have a personal question for you here. What would you say was the trickiest thing that you found when creating this presentation and learning concurrent features, in this case in React?
Well, I think that the trickiest thing I found was diving deep into the source code of React and trying to understand what's going on inside.
Mm-hmm.
Because for us, it's just a simple function that we can import and call it. But the truth is that what I shown, it's just a snapshot of what's going on React. If we go to the performance tab and we try to see everything that is happening, there are a lot of more functions.
Mm-hmm.
I pick only the highlights, let's say, but it's really tricky. It's really straightforward to understanding. For example, the scheduler API. I have never dived deep into it, and I had to do it in order to understand concurrency. But yeah, it's a really good journey, let's say.
And it seems like it was a fun experience as well, digging into the how API is built from the inside, just to make sure, yeah, you fully grasp the concept of it. So one question just popped up. Meanwhile, let's jump right at it. Someone asked, could you tell us a bit about suspense list?
I haven't tested it yet, But yeah, I mean, suspense is something that many developers doesn't know that it exists, because in React 17 it was only for lazy loading components. But
Mhm.
right now that we know that it works on the server, on server side rendering, there's a huge amount of approaches and use cases that came up, but it's something that we still need to dive deep and explore to see it. But
Mhm.
honestly, I have never used suspense list.
Okay, definitely. And I feel like even though there was all that teasing like years ago of when suspense is going to come out, then it
Yeah,
came out, and now I think we're all on the take of okay,
yeah,
let's learn it, let's see how it
yeah.
works, let's see how does it fit into our day-to-day code basis.
Yeah, if you go to internet and try to follow the history of concurrency in React, you will see notes from 3 or 4 years ago,
Hmm.
because it was like they changed the direction in between. At the beginning, they talk about a concurrent mode. Let's say
Hmm.
all React was supposed to work in a concurrent way. Then they switch to talk about concurrent features. So developers are in charge of deciding when to use it or not. So there's a really long history
Hmm.
about it. And I think that this is just the beginning.
Yeah,
I mean,
definitely.
yeah, there are a lot of exciting features coming in React. So I'm pretty sure that this is just the start of the story.
Yeah, exactly. And mentioned a good thing, a cool thing there that I really like as well is considering React RFCs and stuff are public, you can follow the history. You can see okay what happened throughout the years and what led to the product that we have now and the thing that we are all using in this scenario. So it's a very cool thing to be able to look into the history, see what motivated each decisions and how the React team did their decisions with the support of the community.
Yeah, and I mean, for me, the history of the frame of the library that I use every day is really interesting, and it helps us to understand why they took some decisions and why they changed the direction,
Mhm.
and and things like that. So yeah, I think that it helps a lot.
Definitely. Okay, we have two more questions that popped up. Someone is asking that if you said that React 17 was faster than React 18.
Now, what I try to say is that the legacy render model of
Hmm.
React 17, by definition, should be faster than the new concurrent rendering, and
Okay.
that's because giving back the control to the browser of the main thread, handle the events, then going back, continue the rendering, stopping and resuming the rendering will take more time if we compare it
Mhm.
than with executing the same list of tasks in one single pass. That's
Okay.
that's what I said.
Okay. Yeah, I think you explained it very well right now. So, another question that popped up here as well is I think it's how much has React 18 changed the way you write code?
It didn't change the way. I mean, it's just two new hooks that we call it, and that's it.
And
For us, it's real. The concurrency adds really small changes. Of course, there's a new create root function, but
mhm,
that's it. What is really interesting is what happening. The what we don't see when we just call the start transition
mhm,
function. I think that helps us to understand how React works, and that's where it's rich, because React changes the way it works under the hood.
mhm. Okay, yeah, definitely. It makes a lot of sense. And now, in thinking about that perspective as well, so would you say that pretty much okay, the process of adopting these new hooks that showed up was fairly straightforward to you, or did you have to struggle a bit into adopting all these new mindset to go with them, or you're not actually even using them in your code day to day right now?
I have never used any of these hooks in a production code,
Hmm.
let's say, but I use it while I was preparing this presentation. I'm do some test on my side.
Hmm.
Yeah, I couldn't really find a really good use case on production to use it,
Hmm.
but anyway, it's there. It's out of the box. We have to test it and find
Exactly,
those use
exactly.
cases. That's the
Maybe in the
idea.
future.
Yeah.
We have one more question.
Cool.
Someone asked, so did you have some component comments for this construction that I saw on the internet? So it seems that they have a component that's wrapped in the suspense, and this suspense is boundary is wrapped into an error boundary. To and this scenario, I think it's to handle response and errors. It seems so. We're doing some kind of live coding discussion here,
Yeah.
but do you have any comments for this process as well, or how? So let's rephrase this. How do you handle error boundaries with suspense? Have you tried this thing, or is it still
No,
something that you're not familiar?
I haven't tried. I think that this code came from an implementation from the React 17 version
Hmm.
of suspense because we I know that suspense will throw an error if
Yeah.
we throw anything. Well, I mean, we can throw
Hmm.
anything, not even a promise. If there's for some reason there's an error, a suspense will throw that error, and the error boundary will be able to catch that error. Let's say,
Okay. Yeah. So it will probably go bubble up until it gets to
yeah.
the error boundary. Okay. So I don't think we have any other comments showing up. Let's give it a couple of seconds in here. But yeah, meanwhile, while we wait a bit, is there any place that people can reach out to you, Fernanda? Anything place that they can send you messages, connect with you, discuss
Yes,
this
you can.
presentation if they'd like?
Yes, sure. My email is fernando.rosenblit@rootstrap.com, and
Hmm.
you can find me, of course, on LinkedIn.
Okay, amazing. So I
Yeah.
guess we don't have any other questions. So once again, Fernando, thank you so much for your presentation. It was really good. It was a pleasure to meet you as well. So hope we cross paths again in the future.
Okay. Thank you for your time. I really enjoyed being here.
Thank you, Fernando. Have a nice day.
Thank you. Bye bye.